Here we'll look at solving polynomials by factoring. First thing you want to do is get our equation equal to 0, and then factor and apply the zero product principle. So in number 1, we want to solve the following equations. X squared minus 5x equals 0. First of all, notice that we have it equal to 0, which is essential. Now, can we factor that and apply the zero product principle? Well, this worksheet is really just a bunch of practice questions. X squared minus 5x, notice there's a GCF of x. So x times x minus 5 equals 0. So you get x equals 0 and x equals 5 for your solutions. Okay, so if you pause the video and go through and do the next few examples, okay, so there's the first 6 examples. Hopefully nothing too crazy. I think part E is probably the trickiest one. The GCF there is 4x squared. So that's a tricky one. But all the others are straight up applying the zero product principle after you factor. Notice each of those, you start at equal to 0. In the last couple, okay, part G shouldn't be too bad. But then in part H and I, notice that you don't have an equation that's equal to 0. So what you want to do first is get the equation equal to 0. And I always suggest that you keep the x squared term, or the highest degree term, as the positive. So with x squared, if you keep that as a positive x squared, so leave that alone, bring over the 7x by subtracting 7x from each side and add 10 to each side. That'll give you the polynomial you want to deal with. And similar to the last one, if you subtract 6, you would end up with equal to 0 on the right side. Okay, so once you get those two forms, equal to 0, then you can factor and then apply the zero product principle. So pause the video and try to finish those, and I'll put the answers up. So those are pretty straightforward once you get that first step of getting the equation equal to 0. Okay, and then on the second page, sometimes a polynomial may be solved by applying more than one method. So just like with factoring, you might have to use a GCF and then unfoil, or use difference of perfect squares. So you have to use more than one method to factor. Now, you might have to use more than one method to solve. So in the first one, we have x to the third minus 4x equals 0. Well, notice that there's a GCF of x. So that would give you x times x squared minus 4. Notice that x squared minus 4 will also factor. That's difference of perfect squares. So we can factor again to get x times x plus 2x minus 2. Now we have 3 factors. So we're applying the zero product principle still, but instead of just 2 factors, we have that extra factor in front of x. So now there's 3 factors. Same idea though. You set each factor equal to 0. So the zero product principle doesn't matter how many factors you have, you set them all equal to 0. So when you do that, x equals 0, x plus 2 equals 0, and x minus 2 equals 0. So you end up with 3 solutions there. Okay, so if you try the next several, I'll put the answers up again. So I'll put B and C up, pause the video. And then with D and E, in part E, you have to have equal to 0. So again, rather than subtracting 5c to the third, that's your largest exponent. Okay, that's your largest degree of 3. So subtract 40c squared and add 60c. Okay, and then it's ready to use a GCF of 5c. Okay, so if you do those, there's a solution for those. And what I do want to point out is in part D, this one's kind of an interesting one, because if you use the GCF of 3, notice that when you go to set that equal to 0, you have 3 equals 0. That doesn't make any sense. So that is just not part of your solution. Do not confuse that with having 3x or 3n out in front. Then you would get 0 for a solution. But if the variable is not part of your GCF, that means that 0 is not one of your solutions. Okay, so that is using more than one method to factor and solve your polynomials.